Well, welcome. Are you having fun at DevOps? Are you all really tired and want to go home? No. So you haven't come to this
Maybe
talk.
in 50 minutes' time.
You've come to this talk so you can just lay back and be quiet. But we're going to scare you and inform you. So my name is Steve Poole. I'm the one not being abducted. I work for IBM. I'm a developer advocate for the Java team, and so I get to come out and talk about cool Java stuff to you guys.
And I'm Graham Charters. I also work for IBM. I'm an architect and developer advocate on Liberty. So I tend to talk about Liberty and microprofile and stuff.
So we're going to talk to you about something. We've had conversations about this, and it was like, this would make a good talk because it's sort of like new and different, and there's different opinions. And I'm not a security professional by any means, but I'm a sort of interested visitor. And so I have learnt a lot about some of the bad things that we do as developers when we ignore some security stuff. So we're going to talk to you about, you say it, what's it called?
I'm going to call it HATEOAS. I have no idea how to pronounce it.
Or HATEOAS. And some of the security implications and some of the things that you could do to make it less of a challenge. Okay,
cool.
You'll do the first bit.
All right. Yeah. So the title of the talk, how to get along with HATEOAS without letting the bad guys steal your lunch. So I first came across HATEOAS, as Steve was saying, talking to a customer quite a few years ago. So HATEOAS is nothing new. Who here thinks they know what HATEOAS is? Awesome. So I've got to be careful now. I better get it right. So I met a customer quite a few years ago, and they said, we love HATEOAS. It makes writing our client-side applications a lot simpler. They're more flexible. We don't have to change them as often when we change the backends and so on. And so when we were talking, as Steve said, talking together, he said, well, it'd be great to do a kind of security angle to this. So I'm going to start by defining, hopefully, HATEOAS, and going through a little bit, maybe the kind of thought processes I went through as I was kind of investigating this. So it stands for Hypermedia as the Engine of Application State. That's got to be just about the worst name and acronym I've ever come across. But that's what went through my mind. What the frell. So I thought, well, let's break it down a bit and look at what hypermedia means. So hypermedia, this is some kind of dictionary definition. An extension of the term hypertext is a non-linear medium of information that includes graphics, audio, video, plain text, and hyperlinks. So if we try and understand that, let's start with hypertext. Hypertext is essentially text which is all interlinked and so on, so you have a graph of text. But we're talking about multimedia. So things like graphics and audio and video and text as well. So hence hypermedia. So that's kind of okay. We're a little bit wiser maybe. So I carried on digging, and then I came across a really nice blog article by Martin Fowler which talked about something called the Richardson maturity model. Who's come across the Richardson maturity model? Yeah, a few of you. It's not new. It's about, I don't know, maybe about 8 years old. Might even be longer if I'm misremembering the dates. And this was essentially something which was written as part of a book, and it's trying to define a maturity model for doing REST services. And if you're familiar with capability maturity models, there are maturity models for various other types of things, and they always start with a layer 0, and essentially level 0 is where you've done nothing. So you're completely, I guess, incapable. You've not done anything towards designing good REST services. And then they defined 3 layers above where you kind of make this progression through your learning and expertise of doing REST services. So the next one up is resources, so thinking about resources. Next one up is about using HTTP verbs appropriately. And then the last one is about putting in hypermedia controls. So I thought that'd be interesting to kind of look at those in a little bit more detail, because the first one was called Swamp of POX, so it's kind of showing its age, because POX was plain old XML, and we all do JSON now, so it's now the Swamp of Podge. So let's have a look what Swamp of Podge means. And so essentially, kind of layer 0 or Swamp of Podge is you're using HTTP just to tunnel your requests. And what services are implemented in this way typically do is they use the lowest common denominator in terms of HTTP. So they usually just use HTTP post because it can't be cached, and it can't be retried, or shouldn't be cached and shouldn't be retried, I should say. So you're not really using HTTP very well, but you're kind of the lowest common denominator, so things shouldn't go wrong. It's just it's not optimized for the web. And so you define effectively your own little request protocol stuff going on. So here we've got a method called getPerson, and we're providing some data as part of this query, and that's going in the body of the post request, and we'll get a response back. So what I'd like to do with each of these things is show a little bit of demo, and as we're going to go through, we'll see how the different layers become more helpful to the developer. All right, so the first one, this one per Podge. So I've got a service endpoint. It's a single endpoint. That's another point to make. So lots of requests will go over this will hit this endpoint. And so in terms of kind of explaining to the user about this service, there's not a lot I can say because there's so many different types of data that are going to flow over this. So when I try and kind of define an API for it, all it's going to tell me is, well, you can send some JSON and you're going to get some JSON back. But I happen to know that I've got a method property, and I'm going to call it getPerson because that's the method I want to make a request for, and I can get the person with a particular ID. So you can kind of immediately see this isn't very helpful as a developer. I've got no information about the API and so on. So if I execute my request, hopefully I got it right, and yeah, we can see that I've managed to retrieve a person. Okay, so next level up is resources. So this is where you start thinking about resources. So you end up with multiple endpoints. So in my particular example, I've got a person and an address. So I can have a person endpoint for my person resources. I can have an address endpoint for my address resources. But we're still not using HTTP appropriately, so we're going to tunnel things over post requests because I want to pass body data in. So what my request looks very similar. And the response coming back again is going to look very similar. So let's just see what that looks like. So now we can see we've actually got two endpoints, which is nice. So as a developer, I now know that there are more endpoints available, more things I can call, but they're only doing post. But because I'm passing in person objects and getting person objects back, I can perhaps give a little bit more information, a little bit more structure. So, but I don't know what the methods are, but I can kind of maybe guess. Oops, I need to do the try it out button. I can maybe guess, because it's a person object, I might be able to do getPerson. And then let's pass in the ID and execute that again. And we can see we got the person back. So a little bit more helpful to the developer. Oops, wrong way. So next one, HTTP verbs, layer 2, or level 2. So here we actually start using HTTP appropriately. So I'm going to do an update in this particular example. So I'm going to post a person to the person endpoint. Actually, I've got the URL wrong. I shouldn't have given it an ID, but anyway. And then I'm maybe going to get a person back with a generated ID, for example, or I might do a get or a put or a delete, and I may even be able to do patch and head and things like that. So it's using HTTP appropriately, so you can then take advantage of the way the web works, so you can retry certain methods, you can cache certain methods, and so on. So when I look at what's available now, there's a lot more information available to me as a developer. Hopefully you can see that okay. Anyone struggling to see that? All right. Let me scroll it up. Oh, didn't mean to do that. Okay, so I've got various HTTP methods available, and I can do things like, okay, I can do a get, and this is going to give me back all the, well, guessing based on its just at the kind of root of the person resource, it's going to give me back all the people that are defined in my backend. And you might have pagination methods and things like that. So again, it's getting a bit more helpful to the developer, more information for me to see. Last one, hypermedia. So what hypermedia does is it says, well, that's okay returning a resource, but you want to, there's additional information you can provide back. So tell me information about what the things are I can do. Once I've essentially retrieved the state of this resource, where can I go next? So I could always go back to myself, or in this particular example, I can go and navigate to the address resource. This person has an address. But also the kind of, as the engine of state aspect of HATEOAS or HATEOAS or whatever we want to call it, If this person doesn't have an address, then don't give me an address link. You might give me a link where I can go and create a new address based on this person, and that address automatically becomes the address of that person. So this is, again, additional useful information for me as a client, me writing a client application to this REST service. So let's just finally see the last example. So from a kind of from the outside, it looks just like any normal, it looks like the previous example. But now when I do my get and get the results back, I'm getting this. Let me just scroll that up. Getting this additional information, so I can see what my link is, my self link. I can also navigate to the address. Now I haven't actually HATEOAS enabled the address, which is a bit of a shame. But I can go and look at it, and you can see it's a valid endpoint and so on. And that's fine for people and addresses, but this might be banking applications and so on, where some of these things are maybe more useful to you as a developer or perhaps a hacker. Okay, so just a quick summary. So layer 1, you start giving the developer help in terms of resources, understanding what resources are available. Layer 2, you start telling them what the operations are. There's a bit more of a hint about what operations can be performed on the resources. And layer 3 gives you kind of additional state and navigation information about the resources. So all very, very useful. So because this is a security talk, as I was reading Martin Fowler's blog post, I came across this paragraph extract, and I thought it was quite interesting because it kind of summarizes the hypermedia control layer and says the further benefit is that it helps client developers explore the protocol. The links give client developers a hint as to what may be possible next, which is really, really nice. Okay, what happens if we do this to it? It still makes sense. So a further benefit is that it helps hackers explore the protocol. The links give hackers a hint as to what may be possible next. So that's the kind of segue into Steve. I'm going to sit down and enjoy the talk now. And Steve's going to go through the hacking bit.
Can you flick it into dual mode screen? Thank you. Thank you. Okay. I'm going to use this because I'll forget the clicker. So, before we have a big go at this, let's do this. I want to dispel some fake news. Then I'll explain why this is what Graham's just displayed and talked about is really good news. Okay, so many people think that if you have a firewall, everything is okay. Anybody here believe that? Okay, right. So the reality is that having a firewall as the way to prevent people getting into your system is not the greatest answer. Okay, because the bad guys are going to attack every single way, every single part of your system. They're going to find a way of getting in, because we all make mistakes and we all do things that are silly and let people in. So it's no good just saying, hey, I've got a firewall, okay? So your best defense is, animations can be fun, is defense in depth, okay? So when I go through this talk and we talk about some of the problems and some of the benefits, it's not a panacea. There is no complete panacea, right? You have to have solutions all the way through. So we're just going to talk about one part of this. This isn't if you do HATEOAS properly, everything's okay. You still got to do everything else, okay? And you need to do this. You need to have effective detection, right? So one of the biggest problems with our assumptions about how people get hacked is that you would notice, and the answer is that's not true anymore. It's almost impossible unless you've built in systems into the detection systems. You're never going to notice. Okay, so how do they get to you? Okay, so how do people start to break into your system? Okay, there is this view that you have that it's like this is a bank robbery. So I'm going to target you as a bank. That was the wrong example. I'm going to target you as an individual, as an application, and I'm going to look at your system, and I'm going to create complicated plans, and I'm going to measure what you're doing, and I'm just going to figure a way to get it, okay? I'm going to figure my way in. And the answer is, attacks don't start with planning, okay? They start with scripts. So the world that we live in now is like this. So this is a human analogy, but imagine there's a burglar who's trying every door of every building across the planet 24/7. Think of these people out there, these scripts that are trying to get into your system every moment of the day. They're looking for the open lock. So they're not targeting you specifically. There's no plan. They're just finding somebody who's got an open window. Okay? So the other way of thinking of this is that you have this really excited tester who's out there just trying to find bugs in your system, right? Okay, except for he's never going to fill a pull request and tell you that you've got them, but they're going to be doing this. You know those guys that find those complicated problems and they go, look, if you do this, I can crash your system, or if you do this, I can steal data. This is what's happening. They're going to just keep doing that forever. Okay, so how do they get started, right? And I said they go looking for you, right? Well, they use Google, right? They just put words in Google and they find things. So WordPress, that's got an API. In fact, WordPress actually publishes a particular file on a website, on your web server in a certain place that tells you what the API is. It's standard. Great, thanks very much. Or I can go to Swagger Hub where you may have registered your API. Thanks very much. Or I may have gone here. You've done the same. Okay, you've told me what your API is. Or I might just do this. I'm just going to try you and see if I get a response. Okay, so all that has to happen is that you have to respond, okay, or you publish your data, and now I've got an API endpoint. Okay, so what do I do next? How do they start hacking the API? Right, well, you do follow secure design principles when you're writing applications. Are you thinking about these things? Are you thinking about attack surface areas? Defense in depth? Are you looking at failing securely? Any of you guys do any of this stuff? Oh look, one hand at the back. Okay. Big hack, yes. Right, this list comes from the OWASP guys, so I would recommend that you go have a read. So the thing is, however much you do this or you don't do this, the bad guys are trying to figure out where you were not so good. And that's not necessarily you deliberately being wrong, but you just have to make a mistake, right? You're being probed all the time trying to find these mistakes, okay? So there are three parts to how they get to you, and we're only going to talk about one. They're going to try and figure out how you do authentication and access management and try and figure out how to get around that, okay? You may go, I have the best access management, therefore people can't hack my API. And the answer is, well, that's not true, because there are all sorts of ways of being able to get around your security. It's not difficult. You only have to make a mistake and they'll get it. We won't talk about social engineering, which is basically you blabbing about how your system works in places that people can find the information. Okay, and they will also try and find ways to manipulate you to give people access. We haven't got time for that. We're going to talk about the reverse engineering bit. Okay, so as a hacker, if you use REST, okay, thank you, it's Christmas. Because, why? Because you've given me all this documentation. You've told me, Graham demonstrated how lovely it is for me to see how your API works. Okay, I will start just taking, this is all available for scripting. Engines, code can read the Swagger and figure out what to do and just keep prodding, okay? So I can guess how your API works. Okay, I can do get users, and get some data. Cool, thanks very much. I can do users 1, I can get some more ones. I can do users 2, I can get some more stuff. Cool, I'm just exploring your API and I'm getting into your system. Okay, and I can try all the other different ways of verbs and see what happens there. Okay, I can look at your cookies that you're sending backwards and forwards. Can I find information in there? And can I play with that data all automatically, okay, and just see what happens, okay? I'll also go to some of the online services and I'll figure out what your server does. I'll figure out what version of componentry you're running, so I can look for vulnerabilities and okay, I'm just going to go do this, okay? There is this wonderful website called showdown.io, which is an index It's an index of IoT devices. Think of Google, but for IoT devices. And then because it searches all the IoT devices, it searches all the web servers too. And it gives me all sorts of wonderful information. What ports you've got open, what the responses are from probing those points in standard ways, where you are, what software you're running. All sorts of information is gathered by these tools, and as a bad guy I can use this to find you, find your weaknesses. So you know if you've had a vulnerability in your web server, okay, these are going to find it because they're going to find the versions of a particular app server that you've got. They'll have a vulnerability, they'll exploit it, they get in, right? So they're at your system, okay? So they'll do all that. They'll try all these combinations. They'll try these different verbs to see what your code does, okay? I'll just keep playing and trying different things. What do I do with your headers, your cookies? Just play. And I'll try and break your service. Because if I can break your service, then your errors will tell me more things. For instance, I may be able to figure out which part of your componentry is dealing with static files, that's part of your application. Yes, your business logic, this is where you're serving up static files. I might be able to tell that from the errors that you respond, right? If I can find the static endpoint, then maybe I can start to doing things like this. I can start trying to wander around your system, okay? Because you've told me that this endpoint gives me files. So I'll try and do that, okay? And then if things go wrong, that's good too, because you've been very helpful in giving me information about what the problem was. So from stack traces, I can work out what version of software you're running. Thank you. Or Apache Tomcat 8534, thank you very much. What components? Oh, and look, you told me something was wrong. Okay, so maybe I'll try that again and try a different number and see what happens. All of this activity of trying to probe your system is called fuzzing. And there are lots of fuzzing tools. So fuzzing tools are things like, what happens if I try users 1? Okay, what happens if I increment that number? What happens if I put a parameter in that's got some embedded SQL thing? I'm just going to explore your APIs for the edges that you haven't thought about. What happens if I send int max rather than 0 or something like that? Okay. The OWASP guys keep track of all this. You can go read about all this, right? But believe me, it is an enormous space. There are lots and lots of tools out there. It is a professional set. It is very mature. Why? Because it's being produced by the guys who are being paid to test your systems, the pen testers. And then the bad guys make use of this. So look, Artillery Fuzzer, it's a random tool that you can go buy and use and point at your website, and it will fuzz your data and find ways in. Okay? So things like, do you deal with zero wet space in your data? You probably don't even know what it is, but does your code deal with it? Do you understand the side effects that might happen to your system if you have these in there? Right? The big list of naughty strings, best thing ever. It's not really swear words, it's a list of strings that have been shown to have interesting side effects when used on your system. Okay? And it covers all sorts of spaces. So, reverse engineering, fuzzing, this isn't just URLs. It's headers, it's the JSON payloads that you do. When you post something, if I've managed to see what you post or your URL is, your API is properly documented, I can try these things. I'm going to start to figure these things out. Command line options, file formats. So you take an upload for an image. Okay, what happens if I play with the image structure? Can I get your system to break? Can I get you to do things? Can I find vulnerabilities? All automatically. All the time. Okay? Robots, dangerous values, which is people know how to break your systems. Great, fantastic tools, high quality tools to attack your system. But I could do other things, like I could just go read your code on GitHub, and I can do Google searches like in URL, so I can say, tell me all the URLs in the world that has respect.json in them, because that turns out to be the description of a certain type of API. And they are. There's all the stuff. Thank you very much. Or I could ask Google to give me all the web servers it can find that have inadvertently let access to Google for the logs. So I can now look at your logs and see what your URLs look like in your logs and what your errors are and all that sort of stuff. Okay, and I can even get at the logs if you've got an iOS device or an Android device, you've got logs on the phone, I can get at those too, can't I? Because as developers, you put debug information in this stuff, and as a bad guy, I can make use of it. I can find test endpoints just by looking for certain files in Google. This is really cool, right? I've had conversations with people about this before, and people say, we don't use security on our test endpoints because it's easier to test that way. Okay, and then unfortunately your test endpoints get published and get discovered, and now people have got a way into your system by calling your test endpoints, which you don't have security on. Okay. The takeaway right now is it's a really scary situation. Right? The OWASP guys have a whole list of how you can be attacked, and it's worth reading because it will help you be more informed. But you need to understand that it doesn't matter how much defense you've got, these guys are going to be probing you all the time. They're just looking for a mistake that you make, a mistake your IT makes, a mistake that's in one of your dependencies, right? And they will be finding and probing their ways in. Okay. So what has this got to do with REST and HATEOAS and stuff like that? Well, this is a talk about what you can do in this defense in depth. Which bit can you do in the REST space? Okay, so let's do some more bad news. Okay. So when we build REST APIs, we have these wonderful examples that you see, and they're really simplistic, but they are too simplistic and they're very easy to be manipulated because, they're things like get API v1 management departments 10. We're taught to structure these APIs so you as human beings can go, oh yeah, I understand that works and I can code for them. We put them in the documentation. They get printed out. They get searchable. Okay. Why are you putting API v1 in? Okay. Okay. Anything that you can think of that's not API v1, any of the variations that you have invented, somebody else has thought about it and it's part of one of these search terms. So, okay, don't put API v1, put something else that's a bit less obvious but useful to you. Okay. By the way, though, don't put stuff in there that's related to the name of the project. So if you go, hey, we've got this super server, it's called, Darkstar. Don't put Darkstar there because you're going to talk about Darkstar on social media. I was using Darkstar and it didn't work. And the bad guys will catch that and go, what happens if I try Darkstar? Okay. But why do we do this? Because that's what people say and because it's easy. Okay. Right. And then we're trying to make it harder for people, for these bots to get in. Because as soon as they've got a claw in that they understand that they may have found a way in, they're going to try something else. How do we prevent it? How do we make them get bored and move on? Okay, so don't put departments 10, don't have UID, don't have client 1, 2, 3, 4, 5, because I can just guess. You want UIDs for all your entities so that they can't be spoofed. I can't take one of those, change it, and get more data. If I want to guess what the next department is, I have to do something else. Okay. Yeah, and I said about don't do that. Okay. You're trying to make it harder for people to fuzz your data. You're trying to make the robots move on. So you're trying for these basic stuff. Okay. Think, though, about what you think your application is doing. So what do you think you're checking, and what do you think the dependencies that you're using are checking? So, for instance, the path navigation, ... Who checks that? Who makes sure that that's within bounds? Do you do that? Or do you rely on some dependency to do that? Whichever way it is, write some tests to prove that it behaves the way that you want and run them, because at some point it might fail. And that's all the bad guys are looking for. They're not looking for you to change your design deliberately, they're looking for mistakes to get in. Okay? The other thing is about data validation. That's a big topic, but basically if you are not putting lots of effort into how you deal with the data and how you assume that everything's correct, the fuzzing guys are going to break you. Right? There's only so many combinations of data that you should accept, and you should be checking for that. Okay. So the other thing you can do is reduce the data that you return. Okay, so if you have a API v1 users 1 and you return everything you need, then you've just given away. I mean, what would you do? You say, I make this call, it goes to a NoSQL database, I get back some JSON, I give it to the client. Okay, because that's easy. Don't do that. Structure your APIs around use cases and give back just the data that the guys need for that use case. Make it harder for the bad guys to do the discovery. Okay? Don't give back raw data if you can do anything any other way. So often we don't think about just doing a little bit more, a little more clever design. So for instance, if I have a calendar API and I say give me the entries and I get some schedule and I get dates, great, thanks very much, that's a date. I've given information away. I don't want to do that. Okay. What I do is think like this. I want to say, I'm going to call the API and I'll give you some starting position. And then the information that comes back for me is relative to some starting position. You can still code to that, but it's harder for human beings and bots to work out what this is. Because as soon as they understand what this data format is, they can fuzz it. Okay? So it's you thinking about how you can restrict the data you're giving out, but still achieve your goals. You don't have to give out the simple stuff. Okay? So there's a whole bunch of stuff about writing code defensively. Start thinking about the fact that the guy who's calling you could be doing it maliciously, rather than assuming that it's some nice developer that you know down the road is just going to do it for fun, do it right. No, think bad thoughts. Validate all the data. Don't treat the request as an order. Validate it and go, yeah, okay, that's reasonable, I'll do that. Not, okay, it says order 10 million barrels of baked beans. You go, that's a bit wrong. Okay, look at the error messages that come back and make sure they're not too useful. Don't give stack traces unless you really, really have to. Okay, etc. Okay. So one of the things that does happen, what fuzzing is trying to do, fuzzing is trying to figure out how to drive your code down unusual paths. If you have really complicated code, you have paths in here that you're not expecting to be driven. So if your API, if you're data driven and you just read the parameters and you go, okay, if parameter 1's this, I do this, and then if parameter 2 is this, I go down this path, and if parameter 3 is this, I go down this path, I could find myself in some strange part of the code that I never actually expected to get to, but because it was data-driven and I didn't validate it, okay, bad things can happen. And that's what the fuzzing is trying to do, is trying to find how to drive your applications to these weird places, okay? And we don't log very much, so you need to also say when things aren't exactly as you expected, you should be logging. This is all REST stuff, okay? HATEOAS is the next level, and we'll talk about that in a sec. But think about this is just basic REST design thinking. How do I make it more secure? Okay? Think about what you expect the client to be doing. And is the client's request valid and valuable and reasonable at this point? Not whatever they ask, if it passes my filter, it's in. Okay? And then when you do log stuff, log things in such a way that the logging analytics tools that are going to be looking for patterns that you can teach it can find. Don't do, hey, IO exception, if you should be saying file not found or file corrupted, because it needs to know that there are things happening, okay? But don't put too much in your log, because if you put too much in the log, bearing in mind your logs could be compromised, you might be giving information away. It's a hard life. Right, so HATEOAS. HATEOAS can help you. So we need APIs that reduce the ability for data fuzzing, that reduce the ability to drive you down different paths. Cool. Reduce the ability of the machines to probe your API programmatically. We want to make it harder for human beings to figure out what you were doing if they get involved. We want a system that would let you to detect that weird things are happening. Okay, but also ultimately we still want a solution that as developers you've got an API that you can program to. Okay, so does HATEOAS help? Okay, well here's HATEOAS example. Get accounts 1, 2, 3, 4, 5, blah blah blah, some links. Now HATEOAS means, the way that this is structured, it means the Swagger won't tell me what the values of these are going to be. I actually have to make the call to find out what the values are. So that's good. So it's not documented in the Swagger other than as URLs, as endpoints somewhere else. So the relationship is not documented. But as soon as I make one call, I've now figured out what they were, right? So because HATEOAS is intended to do this navigating through the system and making life easier for you, as a developer, it makes life easier for me as a hacker. Okay? Because you're telling me more about what I could do next. You said, hey, valid options that you can do after this point are these. Okay? If you do not understand that you're giving that away, you're helping the hackers. But you can do things with HATEOAS that you can't do with REST that will make all this stuff go away. So, in a traditional REST point, every endpoint can be called in any order. Right? That's the whole point. It's stateless. Cool, right? There's no relationships. So you have any of these endpoints. What happens next? Call any other endpoint. HATEOAS used naively doesn't really make any difference because basically you say after you've called any endpoint, I'll give you a list of all the other endpoints you can call. Right? Because they're all vaguely reasonable things to do. That's the wrong thing. What you're trying to do is say, when I make an endpoint call, I get back a list of valid endpoints, okay, so that they're the only things that you should do next. Okay. However, this does not stop the bad guys calling the other endpoints anyway. You're not restricting their use to a particular endpoint. You're just saying these are valid, but it's just a hint, really. Okay. So you want to say, how do I enforce the behavior, the flow around the system, given that the bad guys can see all the endpoints, can call them directly? Okay. Well, the approach you can take, I mean, it's just one, but you can get the idea, is well, you start off by having a front door. You don't let people go straight to endpoints. You have a front door. And from that front door, you get back endpoints that are reasonable to be called for that activity. So if it's an account, I get some ones that I go, these are reasonable. Okay. The ones that I think are unreasonable, like closing the account, aren't on this list. There'll have to be another call to get access to that state. Okay. And then I start adding information into the URL that lets me track the caller. So I'm not adding state, right? I'm not tying these endpoints to a particular, there's no affinities here, but I'm putting information into the call. So this guy makes a call, I give you some responses, and I give you some unique data. Okay, so let me show you, it looks something like this. So I might have my accounts get a UID back, and I get status, that's going to give me the data, a deposit and withdrawal. And I get the endpoints, but I get magic information attached with it, however you put it in there, whether it's parameters or URIs, okay? Okay? So I'll explain how this works in a sec. So you've now connected the initial caller with what happens next, right? They're linked together. And if I take this basic design principle of separating out the use cases, so the things that are less likely to happen, like closing accounts, they're not even valid. I can't get there from that point, right? So let me show you a different example so you can get it's a bit better in the data. You know, there's all these ways of getting data. I can browse things and you can pass in all sorts of information, like how big the page sizes are and what page number to start up. And those things can be fuzzed. I can put int max, page size minus 100, right? And that's just life. If I take this a design approach, I can validate the front door because I've got this information, and I can look at that and go, that's where I'm going to put my effort in the front door. Once I've got past that, okay, the links that I give back, once that's valid, which could be, say, a list of data, a list of users, each of these isn't user 1 or user 2, it's just an encrypted token. Okay? So the links are still stateless. So I have all these links, and it says, user 1, if you want to edit user 1, call this endpoint. You want to edit user 2, call this. I don't know that's user 1 or user 2. I don't have a UID for the user, but I have an encrypted token. Okay? They're still stateless. I can keep calling them, but every time I call them, I get back another link with a different token, and I'll show you what the token's got in a second. The thing is, these can't be fuzzed. I'm not passing in selection data, I'm passing in something opaque. Okay? So that means that if I had a pet store and I said, give me a list of all the pets by status and a page number, I can get a query back, and the thing says, oh, some random number. Okay? And inside that random number could be all sorts of information that the packer can't influence, but helps you. So, for instance, you can have the real data in, what the query was and what the page size was, but it might tell you how many pages have been processed. It may tell you what the IP address of the caller is, right? It might tell you when you started. When did he make the call to the front door? How long has this been session going on, right? And you're doing this in ways that he can't see that you're tracking, right? And anything else you think you want to do to check the profile of this user and to make sure they're not wandering off and doing bad things, okay? Because this encrypted data is not fuzzable. It's just random. As far as they're code, it's encrypted. It's just a thing, okay? But you have all this actual information about what you could do. So if you want to catch somebody going, this guy's made 15 withdrawals, boom, 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 or he's gone, because I come into a front door, remember, I come to a front door, get a start of a state table, and I can then go off to different places, but he can track me. So I make a call and I go, give me all the people whose name begins with A. Okay, thank you. Now from there I can do a state call that might be another query. Okay, that state query says give me everybody who's got B. Oh, and then I get back another unique link that says, and he uses it to get all the people who've got people dealing with C. Suddenly you could start seeing, because you're tracking it, that this guy's doing something that you think is invalid. Okay? It's just one way of doing it. The thing I really wanted to point out is this is the sort of thing you have to start thinking about how you design your APIs so that you can stop people fuzzing it and giving out this naked information. There's all sorts of ways that you could do this. This is just one example. But this is what HATEOAS as a principle is giving you, this state transition mechanism of going from one place to the other without tying your REST endpoints to any particular service, any particular thread or anything, or any particular app server. It's still stateless, but it's got unreadable tracking information that you can use to track what that person is doing, identify bad behavior. That's what we wanted. So it's not fuzzable, you can see what bad behavior is going on, and you can control the actions of the end user. It's not the only solution. It's not the solution that's going to give you complete peace of mind. But the fact is, it's part of the defense in depth. You should be thinking along these lines about how you're going to prevent yourself being hacked. HATEOAS, whether it's the best or the worst thing of doing it, it's made us think about how we do things. And so that was the sort of thing we wanted to share. Got anything else you want to say?
Nope, don't think so.
Oh, okay. Do I have any more? Yeah, no, you just don't want to know about Ultima. We have 6 minutes left, so I will stop there. If you want to know more about how bad the situation is and how people get into your systems, I'm happy to inform you. But as I said, primarily this is all about defense in depth and about you thinking new ways to design your applications to reduce the ability of these guys to hack you, because they've only got to be successful once. That's it. Thank you.